A country's population is increasing at an annual rate of 2.2%. The current population is approximately 14 million. The growth in population can be modeled by the exponential function p equals p0 times 1.022 to the power of t, where t is the number of years since the population was p0. Assuming the population grows continues at the same rate, determine to the nearest million the approximate population 6 years from now. So in A, 6 years from now means that t equals 6 years. And then it's just a matter of plugging it into, replacing t in this equation with 6. Now p0, right there, that's going to be the starting population size, and that is 14 million. So 14 million, 14 followed by 6 zeros. So this is, instead of writing it like this, I'm going to use scientific notation. I'm going to write 14 times 10 to the power of 6. That's my p0. So now we can plug it in. So p equals 14 times 10 to the power of 0 times 1.022 to the power of 6. And if we evaluate this, we're going to get 15,952,671. Now they want us to answer to the nearest million. So we would round this to the nearest million, which is going to be 16 million, or 16 times 10 to the power of 6. In B, determine the number of complete years required for the population to double. So that means that our P now is going to be 2 times the initial population. The initial population, we refer to that as P0. So this is going to be 2 times 14 million. And this equals to 28 million. So that's the population doubled. So now we can plug this into the exponential function, and this time we're looking for t. So t is going to be the unknown variable. So p equals 28 times 10 to the power 6, 28 million. That equals to p0, which is 14 million, times 1.022 to the power of t. So the first step, once we have this put together, the first step in solving this and finding t would be to divide both sides by 14 million. So on the right hand side, 14 million divided by 14 million just cancels. On the left hand side, 28 million divided by 14 million is 2. So we're left with 2 equals 1.022 to the power of t. Now, to solve an exponential equation like this, we can do that in several different ways. Here, we're going to be using logs. So we can log both sides. So log of 2 equals log of 1.022 to the power of t. And now we can use the log power law. So this exponent here can now be moved as a numerical coefficient in front of the log. So this will allow us to rewrite this as, on the left hand side it remains log 2. On the right hand side we're going to end up with t times log 1.022. In the next step, we divide both sides by log 1.022, which means we're left with t equals to log 2 divided by log 1.022. So at this point, we are going to evaluate this on our calculator. If we do that, we get 31.85, and there are more decimals than that, but they want us to answer in the number of complete years. So we're going to round this to 32 years. And then finally in C, the suggest an appropriate domain and range within the context of this problem. So for the domain, so the independent variable here is t, time. Okay, so we would write t such that, well, what are the permissible values for t? T has to be greater or equal to 0. It cannot be negative. And as long as it is greater or equal to 0, t belongs to the real numbers. The range, the variable here is going to be population size, P, capital P, such that, so according to this model, we start with 14 million, so that's going to be the minimum value, and then it increases. And we don't know what the maximum is. The maximum is obviously not going to be infinity, but within the context of this problem, we're simply going to say that P is greater or equal to 14 million. And as long as it is greater or equal to 14 million, P belongs to the natural numbers. It doesn't belong, it belongs to natural numbers because it's a counting number. We can only have a whole number of individuals. Okay, so natural numbers do not include decimals.